Hi everyone, I continue on the lesson. Now we are going to do topic 8, variation. Before I start to talk about direct variation, indirect variation, I like to give you two examples here. Okay, so let's consider that my speed, for example, I'm driving, my speed is constant, so I don't change it. Of course, if I drive for example, for 1 hour, for example, if my speed is, for example, 30 miles per hour, so you expect that I go just 30 miles. Of course, when I continue to just drive more for more time, then you expect me to just go more distance. Okay, so it's like, so it's like I have distance and time. Okay, so I can write it this way. So distance and time, both are changing the same. So both of them are increasing. Okay, so both of them are increasing or both of them are decreasing. Okay, so for example, if I go for just less time, so of course the distance is less. Okay, so this is what is really touchable, because when I talk about other examples, it's maybe hard to see, but this one is really easy to understand. So when my speed is constant, of course, if I tell you I drive for 5 hours, you believe I have to go more distance than when I drive 4 hours. Okay, so the formula is, in reality, the formula is this: speed is distance over time. Therefore, I have distance equal speed multiple time. Okay, so if I have a speed constant, I can say, okay, this is constant, so I use k as constant. Okay, so it's k time, and then I can see, for example, I use d, I use t, and then I can say d is kt. Of course, you see, if t goes up, d also goes up. If t goes down, decrease, d also decreases. Okay, it's a very touchable example. Okay, so now I have another example. Let's consider the distance is constant. For example, distance from my home to Seneca College. Right now, my Seneca College is in my basement, but if I go to the college, to the location of the Seneca at your campus, so the distance from there to my home, so that's constant. Okay, so if I tell you I walk to the college, you expect it takes me more time than if I tell you I come by the car, because my speed is just more when I go by the car. Okay, so one of them goes up, one of them goes down. Okay, so what do I have here? Here the distance is constant. It's constant. Okay, so it just c, so maybe I just keep it the same as okay, so what happened, I just keep it the same as that. So I just say speed and time. Okay, so speed and time, one of them goes up, speed goes up. Of course, you believe it should take less time that I go the constant distance. Speed goes down, so I go slowly, I walk, I go by bike, so you believe the time should goes up. So this is what we really understand it. Okay, so it's because it's happening every day for us. Okay, so again the formula is like here. So if I want to just keep the pages the same, so the formula is the here. So it's a speed equal distance over time. Now the distance is constant. Okay, so speed is k. Okay, I use a constant here. So k over time, or I can say d is k over t. So dt is k. Okay, see, if you want to compare, this is dt equal k, but here d is kt. Okay, so because k is constant, d goes up, t should go down, otherwise the multiplication is not constant. Okay, so when t goes up, so when t goes up, okay, so let me see what was constant here. Oh, sorry, the distance was constant. I'm sorry. Okay, so that's a speed. I'm so sorry here. Okay, so I just say, okay, so I just say speed or v because we use velocity. So v, sorry about that. I'm thinking it doesn't make, so it doesn't make sense. It's not good that you think about something and do math, because it's absolutely every time I'm thinking about something else and I'm doing it, so it's wrong. Okay, so here is, so if the velocity goes up, I go faster, the time goes down. So when it is this, when it is constant distance, so when the velocity goes down, so I go slowly, maybe I go by bike, maybe I just walk. So you believe, oh my goodness, so she's not going to be here, for example, in 1 hour because she's going too slow. Okay, so the t goes up. Okay, so these two examples are really touchable. So here I say it is direct. I have one constant thing and I have two things which are changing the same as each other, both of them increasing, both of them decreasing. This is direct and here is indirect or inverse. Okay, so indirect because I have a constant thing, and so I have two other things which one of them increases, one of them decreases. So one of them decrease, the other one increase. Okay, so they change just opposite. Okay, so we say this is indirect. So now we can see where is the formula and we can work on other examples. Okay, so the lesson started from here, but from my point of view, based on my experience, when I talk about distance, speed and time, it's very touchable for the students. Okay, so I like to do this. So now we do the lesson here, means I talk about another example. Okay, so if pressure remains constant, okay, many times I have to say we keep things constant. Okay, so if pressure remains constant, the ratio of volume to the temperature is constant. Okay, sorry for the noise. So the ratio of volume to temperature is constant. Okay, so this means V over T is K, which is constant. We call K constant of proportionality. Okay, in this case, for this lesson, when we talk about direct and indirect, we say constant of proportionality. Okay, so what happened here? Okay, I have V equal KT. Okay, so what do you expect when you compare it with two other examples? Okay, two other examples. This example, K is one side, VT is one side, and here D is one side, KT. Okay, so here is V equal KT. Okay, but the T there is time and the T here is temperature. Okay, so it doesn't matter. I can use any variable. Okay, so I can have any variable. Okay, so what do you see here? What happened? Okay, if temperature goes up, volume goes up. Okay, look at here. The temperature going up, volume going up. When the temperature is coming down, volume is also coming down. Okay, so this is direct variation because both of them are changing the same as each other. Okay, so now I tell you what happens if I double temperature. So if I double temperature, volume also has to double. So I think about it. Okay, so I think yes, it has to. But how do I really show this? See, I have V equal KT, right? Double the temperature means you multiple. So you have V equal KT. You multiple this side with 2 because temperature multiple to double. Of course, when they are equal, I have to multiply the other side as well with 2. Okay, so I have to do this and then I have to say this is 2. Yes, the volume also doubles. Okay, I can show it this way. This way is totally correct, but it's not really mathematically. Okay, so I use mathematically later. Okay, so if you go by this method, I give you full mark. If you go by mathematically method, I give you bonus mark because that's just with more details, but both of them are correct. Okay, so here, okay, V equal KT. What happened? If I cut the volume, okay, so if I have V divided by 2, what happened to the temperature? Oh, okay. Yes, here also I have to, so maybe I just do this. Here also must be this. So the temperature is also divided by 2 because I have one equation and I divide one side by 2, so the other side has to divide by 2. Okay? Therefore, any increase or decrease in V gives me increase and decrease in T. But in future, you will see questions that it's not always double. For example, maybe one of them double, one of them multiple 4. One of them double, one of them multiple 6. Okay, so we will see. But when both of them increase or both of them decrease, we say they vary directly. Vary means change, and the lesson is variation. So we have variation of two things when other things or one thing is constant. So vary directly. Okay, so here indirect variation or vary indirectly. Exactly the same question that I just the example I used, so is here. Imagine you are on the way to a school, way from home to school. Okay, when you, for example, your speed, so let me see, normally it takes you 30 minutes to go. Now you double your speed. Okay, what do you believe? You double your speed, so of course you believe it shouldn't take you 30 minutes, it should take you less because you are going faster. Okay, so the time has to go down. See, speed goes up, time down. So this is indirect variation. They vary, they change, but indirectly means opposite. One of them up, one of them down. So yes, when you double the speed, time goes half. How can I show this? Okay, how can I show? So here is this. Speed is distance over time. Distance is constant. Okay, so S is K over T. Okay, so S, T is K. Okay. So I multiple s with 2. So I have 2 st equal k. Remember, k doesn't change. So of course I have to divide this by 2. Otherwise, doesn't make any sense because I need to have k, so I need to have something to cancel 2. When I multiple speed with 2, then time goes half. Okay, and I can show it here. Therefore, any increase in speed decreases time, or vice versa. Okay, so in this case I say they vary indirectly. They vary, yes, of course, both of them are changing, but one of them goes up, one of them goes down, or opposite. Okay, so now I have both formula here on one page, okay, for both type, because I want you to see it. Okay, so direct variation, I say y varies directly as x, and I show y alpha x. So when I say direct variation, you can write y alpha x. Okay, this means y is proportional to x. Proportional means both of them just vary directly. Or I can say y varies directly as x, or I can say x increases, y increases, or x decrease, y decrease. Okay, the other one, if I say indirect, is y alpha 1 over x. Y alpha 1 over x, because its y goes up, x goes down here. Okay, so it's this case. And I say y varies proportional, or I say y varies indirect, or I say y increases, the y decreases. Sorry, x increases, y decreases, or I say x goes up, y goes down. Okay, they change, not the same as each other, opposite. Okay, so this is what you say when you say direct variation. This is what you do when you say indirect variation. But how do you write it? How do you write it mathematically? This is what you say. This is a symbol. Y alpha x is a symbol. When I say y varies directly, y alpha x. Y varies indirectly, y alpha 1 over x. But how do I write it? The way that I write it is ykx, and that k is the constant of proportionality. That thing is constant. The same as distance that was constant in indirect one, or speed was constant in the direct one. Okay, so that's here. And here I use y k over x. Then what happened? Here I have y over x equal k. Here I have xy equal k. When you find k, it really helps you, because when I talk about two situations, for example, I say I have this situation and what happened if I do this, then you really need to find k. Wherever I say this is happened now, and how about this is later, exactly the same as proportion that you had in review ratio, so 5. Okay, so you need to find k. So when you find k, it helps you to find the formula, because k is constant, k doesn't change. So if I have two situations, when k doesn't change, I can find the formula between situation number 1 and situation number 2. Look at here. This is situation number 1, k is constant. This is situation number 2, I can find the formula here. This is situation number 1, this is situation number 2, and k is constant, so I can find the formula here. So now I can say y1 for direct, y1 over x1 equal y2 over x2. And here I can say, okay, I have this one, I have this one, I have this one, I want to find this one. Or any of them. I have 3 of them, I want to find the 4th one. Here, x1, y1 equal x2, y2. So I have this one, I have this one, I have this one. For example, I'm looking for this one. Again, any of them. I have three of them. I want to find the fourth one. So when I have direct, I do this. When I have indirect, I do this. I have both of them beside each other because I want you to see it. Okay. So force F of a moving object. So now I do example. Force F of a moving object varies directly with mass m. Okay, maybe in reality you know what is the constant, and the constant is not really constant, but when I say it doesn't remain constant, but when I say this is directly varies, or varies directly, varies indirectly, I keep in my mind that the other thing is constant. Okay, so force F. Okay, write the relationship. Okay, the relationship as an equation. So F alpha F varies directly m alpha m. Okay, how do you write as a equation? F k m. Okay, maybe we know k is not, so for example k is watt, or in physics, so for example that has a name, that has another symbol. But remember, when I say vary directly, vary indirectly, I keep it constant. Okay, so how does the force change when mass is doubled? Okay, so F is km. So I have F multiple this equal K to M. Okay, remember equation is just F is Km. When mass is doubled, also of course F is also doubled. This way, correct and full mark. But if you do it mathematically, I like to show you mathematically as well. And so maybe every time I do just one of them. Okay, so listen, I have F. Okay, so I have F1 equal Km1. I have M2 equal to M1. Okay, I want to know what happened for F2. Okay, so how do I do this? Okay, so here F2 is Km2. Okay, so this is the formula that you have for every situation. M1, F1, M2, F2, M3, F3. So F2 is Km2. What is M2? K2M1. Oops. So this is 2Km1. What is Km1? That's 2F1. So how do I know here? Here I say, okay, so I use this one with this one here, and I use this one with this one here. Okay, see, this is mathematically, I'm doing mathematically, logically, mathematically correct. I have some assumption, and I have something I want to find, and I really find it using those facts. Okay, so now how does force change when mass is half? Okay, so F is Km. F is Km, for example, divided by 2. So of course this one has to divide by 2. Otherwise it doesn't make any sense. So half is also, sorry, F is also cut in half. Okay, this is correct, totally correct mathematically. Mathematically, oops, F1 is Km1. M2, oops, is M1 divided by 2. So F2 is km2. What is m2? km1 divided by 2. What is km1? f1 divided by 2. Yes. Okay, so what did I use here? So here I use this here, and here I use this here. Okay, this is mathematically. So how would the mass have changed to result in a force that was 5 times greater than the original force? Okay, so I have F equal Km. If I want to have 5F, so of course I have 5K, 5M. Okay, so how do you write it? Yes, mass is also 5 times greater than the original mass. Okay, you can do it this way, you can do it mathematically. I give you bonus mark. Okay, so here, so if the force is 5 Newton when the mass is 3 grams, what is the volume of, no, sorry, what is the value of constant of proportionality? Okay, here I want to find K, constant proportionality. Constant proportionality is F, is a K, sorry. So F is K M, right? Okay, so K is F divided by M, so it is 5 Newton, so per 3 gram. Okay, divided by 3 gram. Okay, so that's a constant. So remember, this doesn't change. In reality, maybe yes, but in the question, we keep it constant. Okay, so we believe that's constant. So for the next situation, for the next value, when I change F, when I change M, this is constant. I don't change it. And that's why I can say when one of them is double, the other one is double. When one of them is half, the other one is half. So if the mass is changed to 12 gram, what is the force? How can I find it? Oh, now I know K. Okay, so look at this. I have F equal 5 Newton per this 3 gram and multiply by 12 gram. So gram and gram cancel, this and this. Oops, maybe I changed the color. So here, yes, gram, and yeah, I made such a mess. This and this, and then I do this and this, so it's 4. Okay, so it's 20 Newton. I look at the units. I really have to pay attention to units. For example, maybe one of them is here is gram, and when I want to give you part F, I talk about kilogram. Okay, so it doesn't make any sense. I have to do conversion. But here, no. Okay, doesn't matter. Okay, look what happened here. What happened here? Here, I give you one of them and I want the other one. I give you M and I want F. In this case, you need to know K. You need to know what is K. So you need to have more information, means you need to have another situation which F is known, M is noun, both of them, and you can find K. So in this case here, I am giving you situation number 1, and I am asking you for situation 2. Situation number 1, F is 5, mass is 3. Now what is F when mass is 12? Okay, by situation number 1, I find K, and then I use K to solve situation number 2. Okay, so now I can finish the first video here, and I can continue for the lesson after. Thank you for your time. Bye.